Hello friends, welcome to the discussion of another topic in mathematics for the purpose of excelling in CSAT examination. Today's topic is pipes and cisterns, which is based on the basic concepts that we had learned in the session for the topic time and work. Now here, let us say that we have a tank and there could be two inlet valves, let us say, which will fill water into this tank, and there could be one outlet valve, let us say, which would be emptying this tank. Now this is valve A, this is valve B, and this is valve C. So the only difference with respect to the basics that we had learned in the topic time and work would be the inclusion of valve C, which is an outlet valve C. So here valve A and valve B, let us call them taps. So tap A and tap B, they carry out the positive work of filling the tank with water, whereas tap C, which is an outlet tap, empties the tank. So this is doing negative work. So this is the only difference, and wherever applicable, we shall see how to resolve such kind of questions. Let's have a look at the very first question. Each of the two taps A and B can fill a tank with water in 12 hours and 15 hours respectively. If both the taps are open together, then in how much time will the tank get filled? So both the taps A and B are doing positive work, so we will use the LCM method. That is, A can fill the tank in 12 hours, B can fill the same tank in 15 hours. The LCM of these two numbers is 60, 12 into 5 is 60, 15 into 4 is 60, and 5 plus 4 units of work, that is 9 units of work, is being done by A and B together. So 60 is to be divided by 9 because 60 is the total units of work, and A and B working together will do 9 units of work. So hence the total time taken for A and B together to fill the tank will be 60 by 9 hours, that is 20 by 3, which is 6, 2 by 3 hours. Now this shall be the answer for this question. Look at the next question. Tap A and tap B can fill a bucket with water in 12 minutes and 15 minutes respectively. If both the taps are open at the same time and tap A is closed after 3 minutes, then in how much time will the tap B fill the remaining bucket? So we see that tap A gets closed after 3 minutes, which means that for the first 3 minutes, A and B, both the taps were open simultaneously. So if we draw a timeline here, 3 minutes of work was done by both A and B, after which A was closed, and for X minutes, tap B alone was opened, and in these X minutes, tap B was responsible for filling up the remaining bucket. Now here, how much work is done by both the taps A and B, which were open for 3 minutes? For that, first of all, let us find out the working capacity of A and B together. Now A can fill this bucket in 12 minutes and B can fill this bucket in 15 minutes. We know the LCM is 60. So once again, this is into 5. This is into 4, total is 9, so 60 divided by 9 shall give us 20 by 3. So 3 minutes of work done by A and B together. Now A and B together in 1 minute can do 3 by 20 of work because they are completing the whole work in 20 by 3 minutes. So let us say this is 3 by 20 by 3, so 3 goes up, so into 3, plus X minutes work done by tap B. Tap B alone can fill this bucket completely in 15 minutes. Together they fill up 1 bucket. So as of now, in these two questions, we have not encountered any leakage or the outlet tap. These questions are to be treated and solved in the same way as we have solved the questions in the topic time and work. So we can say X by 15 is equal to 1 minus, well, this is 3 into 3, 9, 9 by 20 goes here. So 9 by 20, we shall get an 11 by 20. 5 3s are, 5 4s are. So x here becomes 11 by 4 into 3. That is 33 by 4 minutes. Further, this can be resolved as 8 1 by 4 minutes. That is the value of x, which is the time taken by B to fill the remaining bucket. So this shall be our answer. Next question. Two taps A and B can fill a tank with water in 20 minutes and 1 hour, respectively. If initially both the taps are opened together for 10 minutes and then tap A is closed, then in how much time will the tap B fill the remaining tap? Once again, take the timeline. Initially, both the taps were open for 10 minutes. So 10 minutes work was done by A and B together. Then tap A was closed and tap B was the only tap which was open. Then in how much time will the tap B fill the remaining? It will fill it in X minutes. So this question is similar to the last one, only difference being the figures here. So A and B, let us find out their working efficiencies. 20 and 60, 1 hour, 60 minutes. So LCM is 60, 20 into 3, 60 into 1 becomes 4. So 60 here to be divided by 4. A and B together can fill this tank in 15 minutes. But what happened? A and B, they worked only for 10 minutes. So how much amount of work did they do? Well, in 10 minutes they could fill 10 by 15 of the tank. Plus in X minutes, B did X by 60 of the work and together they filled this tank. Now 10 by 15 we know is 2 by 3. Let's take it here. So we get X by 60 is equal to 1 minus 2 by 3, which is 1 by 3. 3 and 60 cancel, goes by 20. So X equals 20 minutes. That is, B took 20 minutes to fill up the remaining tank. This shall be the answer. Next question. 3 pipes, A, B and C, can fill a tank together with water in 6 hours. Initially, all the 3 are opened at the same time and then tap C is closed after 2 hours. If tap A and B together can fill the remaining tank in 7 hours, then in how much time tap C alone would have taken to fill the tank? Taking the timeline here, it's given that A, B and C together can fill a tank in 6 hours. All are opened at the same time and tap C is closed after 2 hours. So for this 2 hours duration, A, B and C, all the 3 taps were open. Now tap A and B together were still open after 2 hours when C got closed, and they took 7 hours to fill up the remaining tank. So from this we know 2 hours work done by A, B and C is 2 by 6 plus 7 hours work done by A and B. We don't know, A and B combined together would have taken how many hours to complete this, to fill this tank. But together they fill up this tank. Becomes 1 by 3, goes to the other end. So 7 by A and B is equal to 1 minus 1 by 3, which is 2 by 3. So A and B have the capacity to fill up this tank working together in 7 into 3 by 2, which is 21 by 2 hours. This is equal to 10.5 hours. Now, A, B and C can fill up a tank in 6 hours, and A and B together can fill up the same tank in 10.5 hours. Now 6 and 10.5, what will be the LCM? 10.5 is not divisible by 6. 10.5 into 2, 21, not divisible by 6. Again, 21 plus 10.5, that is 31.5, not divisible by 6. Again, plus 21, again, plus 10.5 would make it 42, which is very much divisible by 6. 6 into 7, and this shall be 10.5 into 4. Now, what is it that we require? Well, we want to know that how much time tap C alone would have taken to fill the tank. Well, if you take away this A and B, what is left over is C. A, B, C together do 6 units of work in 1 hour, and A, B and C together 7 units of work in 1 hour. A and B, they do 4 units of work in 1 hour. So C alone should do 7 minus 4, that is 3 units of work in 1 hour. So what do we have now? 42 divided by 3. So 42 by 3, which is nothing but 14 hours, that shall be our answer. So tap C alone would have taken 14 hours to fill the tank on its own. Now, a tap was supposed to fill a reservoir with water in 16 hours. But due to a leakage in the reservoir was filled in 24 hours. So let us do one thing. The tap which is filling the tank, let us name it as A, and the tap and the leakage, let's name it as B. Now when the reservoir is full with water and the tap is closed, then in how much time will the reservoir become empty due to the leakage? A tap was supposed to fill a reservoir with water in 16 hours. So tap A would have filled this tank in 16 hours. But then tap A and leakage both were operating at the same time. So the tank in actual got filled in 24 hours. Because B here has done a negative work. That is, it is trying to empty the tank, whereas tap A is trying to fill the tank with water. It is doing positive work. Now 16 and 24, the LCM is 48. So into 2, we want to know in how much time B alone, that is leakage alone, can empty the tank. And as it is doing negative work. So B or leakage alone can empty the tank in 3 minus 2. We get 1 here. So 48 is divided by 1. Obviously 48 hours is when this tank will get emptied due to the leakage. Next one, 2 valves A and B can fill a tank with water in 10 and 20 minutes respectively. The tank full with water can get emptied in 40 minutes by an outlet valve C. Now if all the 3 valves are opened at the same time, then in how much time will the empty tank get filled completely with water? Now all the valves A and B, the inlet valves, and C, which is the outlet valve, they are open at the same time. So let's find out their working capacities when they are working together. A can fill the tank in 10 minutes, B can fill the tank in 20 minutes, whereas C can empty the tank in 40 minutes. Now 10, 20, 40. The LCM obviously is 40. So 10 into 4, 20 into 2, minus 40 into minus 1. So it becomes 4 units of positive work, 2 units of positive work, and 1 unit of negative work. So 4 plus 2, 6 minus 1, we get a 5. So when all A, B and C are open together, then in 1 minute, 5 units of work is done. Total units here are 40. So divide that by 5. So 40 by 5 gives us 8. So when all the 3 valves are opened, the tank gets filled in 8 minutes. Now 2 taps A and B can fill an empty tank with water in 3 hours and 4 hours respectively. And tap C can empty a full tank in 2 hours. If all the 3 taps are open together, then in how much time will the empty tank become full with water? Similar kind of a question with different figures. So A, B and C, let us register this concept properly into our mind. 3 hours, 4 hours and 2 hours. So 3, 4 and 2, the LCM is 12. 3 into 4 is 12. 4 into 3 is 12. And 2 into 6 is 12. But mind you, this is doing negative work because tap C can empty a tank. So hence 4 plus 3 minus 6, which is 1 unit of work which is done in an hour when all A, B, C are opened at the same time. So 12 by 1, 12 hours is the time taken to completely fill the tank with water. This shall be the answer. Look at the next one. 3 taps A, B and C can fill a tank with water in 6, 8 and 24 minutes respectively. Initially all the 3 taps are opened at the same time. But tap C was closed 2 minutes before the time at which the tank got filled completely with water. Now find out the total time taken for filling the tank completely with water. What do you need? Total time. Read the question carefully. You should know what is the demand of the question. So now let us take the timeline, because it says that initially all the three taps were opened. So initially A, B and C, they worked together in filling the tank. And C was closed 2 minutes before the time at which the tank got filled completely with water. So here C was closed 2 minutes before the tank actually got filled. So for these 2 minutes, which were the taps which remained open? Obviously A and B, because C has been closed. And A, B and C, all the three taps initially were open together for how much time? We don't know. So let's find it out. Let's name it as X, because it is the unknown. Now, let us try and find out the combined efficiency of A, B and C and A and B. So we have A, B and C. A can fill this tank in 6 minutes, B in 8 minutes, C in 24 minutes. So 6, 8 and 24 for these three figures. The LCM is 24. 6 into 4, 8 into 3, 24 into 1. So together A, B and C would do 4 plus 3 plus 1, that is 8 units of work in 1 minute. Total units are 24. So divide it. So 24 by 8, the tank would have got filled in 3 minutes if A, B and C, all the three taps were open from start to end. Now here we need the working efficiency of A and B as well. So let's find this out here. 6 and 8, once again, the LCM here is 24. So into 4, into 3, total is 7. So A and B together would have filled this tank in 24 by 7 minutes, if these were the only two taps which remained open. Now let us use this information and fill it into the timeline. So X minutes of work done by A, B and C. A, B and C together can fill this tank in 3 minutes. In X minutes, they fill X by 3 portion of the tank. Plus 2 minutes of work done here by A and B. So it is going to be 2 by 24 by 7. So 7 goes to the top. So together they complete a work. And that is filling the tank. Now this 2 cancels this 24, becomes 7 by 12. This 7 by 12 goes here. So X by 3 is equal to 1 minus 7 by 12, which is 5 by 12. 12 and 3, they cancel. So X here equals 5 by 4 minutes, which is 1 by 4 minutes. Wait, this is not your answer, because the question is find out the total time taken for filling the tank. So total time taken here is X plus 2. So total time taken to fill the tank is X plus 2 minutes. X here is 1 by 4 minutes plus 2 minutes. So in total 3 1 by 4 minutes was the time taken to fill up this tank completely as per the given conditions. So this becomes our answer. Look at this one. 3 taps A, B and C can fill an empty tank with water in 10, 20 and 30 minutes respectively. Now an outlet tap can empty a tank full of water in 15 minutes. Name is not given, so let's name it as tap D, the outlet tap. If all the 4 taps are open at the same time, then in how much time will the tank get filled completely with water? The process remains the same. Instead of 3 valves, now you have 4 valves or 4 taps. So let's use the LCM method to find out their combined efficiency. A 10 minutes, B 20 minutes, C 30 minutes, and D can empty the tank in 15 minutes. Mind you, D does negative work of emptying the tank. So 10, 20, 30 and 15. The LCM here shall be 60. So 10 into 6, 20 into 3, 30 into 2, and D here is emptying, so it has to be minus 4. So into minus 4. So their combined efficiency, or the amount of work done by them in a single minute, will be 6 plus 3 plus 2 minus 4. So 6 plus 3 is 9 plus 2 is 11. 11 minus 4 is 7. So 60 gets divided by 7. So 7 8s are 56. Remainder is 4. So 8 4 by 7 minutes shall be taken by all these 4 taps when they are open together to fill the tank. So this is the answer. Now look at this one. A tap of 2-inch diameter can fill a tank completely with water in 1 hour. If the diameter of the tap is doubled, then in how much time will it fill the tank completely with water? Well, when we say a tap of 2-inch diameter, that means the tap has to be circular. So initially, when the diameter is 2-inch, we can say that the radius is 2 by 2, that is 1 inch. And when the diameter doubles, that is 2D, that becomes 2 into 2, that is 4 inch, then radius is 4 by 2, that is 2 inch. Now initial and double diameter. As per that, let us take the ratio. So ratio of areas for initial diameter and double diameter. See, it is going to be pi into r square, and r here is 1. So we know that the area of a circle is pi r square, so we are just using that. Whereas when you double the diameter, then the area becomes pi into radius is 2 inches, so 2 square. Pi and pi, it cancels here. So this becomes 1, this becomes 4. So simply, let us say when 1 liter of water is filled in 60 minutes, because the given time here is 1 hour, then 4 liters of water will get filled when the diameter becomes doubled. So then in how much time will the tank completely fill with water? So 4 liters of water gets filled in 60 minutes. 1 liter of water with this double diameter will get filled in how much time? That is 1 by 4 into 60, 15 minutes. So if you double the diameter of the tap, then the tank will get filled in 15 minutes. Now, the 3/5 part of a water tank is filled with water. When 38 liters of water is taken out of this tank, then the tank is only 1/8 full. Find out the total capacity of the water tank in liters. Now, the total capacity of the tank we need to find out. So let it be x liters. Now it is given to us that 3/5 part of a water tank is filled with water. So how much water is presently available in the tank? It is 3x by 5. When 38 liters of water is taken out of this tank, so 38 liters is taken out, so minus 38 from this much amount, then the tank is only 1/8 full. Now this means that the tank will be only 1/8 full. Total capacity is x liters, 1/8 of that is x by 8. So a simple equation we get. So we have 3x by 5 minus x by 8 equals 38. So taking LCM here, 24x minus 5x by 40 is equal to 38. This means 19x is equal to 38 into 40. 19 into 2 is 38. X is 2 into 40. That is 80 liters. So what we need to find out? The total capacity of the water tank, which is x liters, works out to be 80 liters. That is the answer. Alright, 2 taps A and B can fill a water tank in 10 minutes and 15 minutes respectively. A man opens both the taps at the same time. The time at which the tank should have been full with water, it was found that there was an outlet tap which remained open accidentally. Now the man closes the outlet tap and then the tank becomes full of water in next 4 minutes. So find out in how much time can the outlet tap empty the tank full of water. So what happened here? Initially tap A and B were opened to fill up the tank. Let us say that they were supposed to fill up the tank in X minutes. So the man came. After X minutes he checked. The tank was not full. So he looked for leakages and he found out that another tap C, which is an outlet valve, accidentally remained open from the beginning. Now he closed it. And after that, 4 minutes of time was taken by A and B together to fill up the remaining tank. Now he's asking you in how much time this outlet tap C, we're going to name it C, will completely empty the tank full of water. So if we go through the timeline, we find that initially A, B and C, all these taps were open, where A and B were doing positive work of filling the tank and C did negative work of emptying the tank. And they remained open for we don't know how much time. Let us find out for how much time. Well, he says that A and B together were supposed to fill up the tank. And the man had no idea that C was also open. So he expected that A and B will fill the tank in a particular time period. In how much time? Well, let us find out for A and B. A can fill up the tank in 10 minutes. B can fill it in 15 minutes. 30 is their LCM. This is into 3. This is into 2. So this is 5 units of work done in 1 minute. 30 units of work. So 30 by 5, that is 6 minutes. In 6 minutes, the tank should have been full with water, assuming that A and B are filling them. So C was also open without knowledge of the man. So that means A, B and C, these three taps remained open for 6 minutes together. Now what happened after 6 minutes? Tap C was closed. And then tank becomes full of water in the next 4 minutes. So it took 4 minutes for A and B together to fill up the remaining tank. So we need to know 6 minutes work of A, B and C. Well, let's try and find this out. So from this, 6 minutes work done by A, B and C plus 4 minutes work done by A and B. A and B together can fill up the tank in 6 minutes. So in 4 minutes, they fill up 4 by 6th of the tank. Together, they fill up a tank. That's the story. So this becomes 2 by 3, goes here. So 6 minutes work of A, B and C together is equal to 1 by 3. So from this, we find out that A, B and C together can fill up the tank in 18 minutes. Now let's use LCM method to find out the working capacity of C. A and B can fill up the tank in 6 minutes, whereas A, B and C together can fill up the tank in 18 minutes. LCM is 18, this is into 3, this is into 1. So we just reduce these two figures. So 3 minus 1 is 2. 18 when divided by 2. C can empty this tank in 18 by 2, that is 9 minutes. That is the capacity of C to completely empty a tank full of water. So friends, these were certain questions based on pipes and cisterns with various difficulty levels and varieties introduced. We will meet again in the next session. Till then, my best wishes for you. Stay safe and thank you.